Okay, in this video, we're going to look at example number 2 of ellipses. So in this example, we want to find the equation of each ellipse. So it's going to be helpful with this type of examples to work on some kind of sketch as we seek to find the equation. So in the first example, we've got an ellipse with vertices at plus or minus 80, and the minor axes were given to be 6. So let's just make a sketch of that. So vertices plus minus 80, minor axis is equal to 2b. So 2b is equal to 6. So let's do a sketch of this. So we have got a vertex at 80, got another vertex at minus 80, which means the center is at 0, 0. So this is telling us that the ellipse is going to be oriented like this. So the major axis is horizontal, and since 2b is equal to 6, it means b is equal to 3. So this is going to be 0, 3 there and 0 minus 3 there. And the distance from the center to each of the vertices is a. So a here is equal to 8. So in terms of finding the equation, this is good enough to find the equation. You don't need to see. So the equation is simply going to be x squared divided by a squared, and then plus y squared divided by b squared equal to 1. Alright, and then in b we have got a vertex at 0, 13, a focus at 0, minus 12. B, we've got a vertex at 0, 13, at focus at 0, minus 12. We have got as the center at 0, 0. Okay, so just do a rough sketch. 0, 13, we have got a vertex. So there's going to be a vertex somewhere there. Center is here, which means the other vertex is at 0, minus 13. So this ellipse is going to look something like that. The major axis this time is along the y-axis, and so A is going to be 13. We have got one focus at 0, minus 12. 0, minus 12. So distance from the origin to the focus is equal to c. So that means c is 12. So from this we can now find b squared. Remember, b squared plus c squared is a squared for the ellipse. So here b squared is going to be a squared, which is 13 squared, then minus 12 squared. So that is going to be b squared. 13 squared is okay, so it's going to be 169 minus 144. So that's going to give us 25. So once we've got a and b, we can now write the equation. Now, so remember this time, a squared is going to be dividing the y squared term. So it's going to be x squared over 25 plus y squared over 169 is equal to 1. Alright, then we go to example number C. So in C, we have foci at plus or and minus 10, and eccentricity is 5 over 6. Okay, so foci plus or minus 10, 0. Eccentricity is 5 over 6. So in all cases, we want to find the coordinates of the center. We want to find the values of a and b, and then we have got everything. So I've got focus at 10, 0, got focus at minus 10, 0, which means the ellipse is going to have a horizontal major axis. So the distance from the center, which is going to be the midpoint between 10, 0 and minus 10, 0, so the center is 0, 0. Distance from the center to the focus is C. So this is telling us that C is equal to 10. Then we know that the eccentricity is C over A. So that means from here we can find A. So since the eccentricity is 5 over 6, C is 10, then it means A is going to be 60 over 5. So that's going to be like 12. So A is going to be equal to 12. And then now we can find B. We know that C squared plus B squared is A squared. So B squared is going to be A squared minus C squared. So that means B squared is going to be 44. Then now we can write the equation of the ellipse is going to be x squared over a squared. So that's going to be 144. And then y squared over b squared equal to 1. Then we go on to D. In D we have vertices at 8, 3 and minus 4, 3. So vertices 8, 3, another vertex at minus 4, 3. We have got one focus at 6, 3. So one focus at 6, 3. So again, let's do a sketch. So we've got things happening at y along y equal to 3. So at 8, 3, we've got a vertex 8, 3 minus 4, 3. We've got another vertex. So the midpoint of these two must be the center. So if we add 8 and minus 4, we get 4 divided by 2. So the center is going to be at 2, 3. So the ellipse is going to have a horizontal major axis, and A is a distance from the center to n of the vertices. So A is going to be 6, and then we're told that one of the foci is at 6, 3. So got a focus here at 6, 3. So the distance from the center to the focus is C. So C is equal to 4. So again, from here we can find B squared. Going to be 6 squared minus 4 squared. 6 squared is 36. 4 squared is 16. So that means B squared is going to be 20. So the equation of this ellipse is going to be x minus 2 all squared divided by 36. The 2 is the x coordinate of the center, y minus 3 squared all over b squared, which is 20. So that is D. Okay, next we're going to go to E. In E we have got directrices given by the equations. 4y minus 33 equals to 0, and 4y plus 17 equal to 0. So we've got 4y minus 33 equals to 0, 4y plus 17 equals to 0, and then we're also told that the major axis is along x plus 1. So major axis along x plus 1 equals to 0, and the eccentricity is 4 over 5. Okay, so we're going to start with the directrices. So the first one is y equal to 33 over 4. The other one y equals negative 17 over 4. Then the major axis is along x equals negative 1, so that means the center must be somewhere along this line. So we need to find the midpoint between these two. So that midpoint is going to give us the x coordinate of the center. So that x coordinate is going to be 33 over 4 plus negative 17 over 4 all divided by 2. 33 minus 17 is going to be so 33 minus 17 is 16. So this is going to be 16 over 4 divided by 2. It's going to be 8 over 2. Now it's going to be 4 over 2. So it's going to be 2. So this is telling us that the center is going to be at minus 1, 2. So the center is at -1, 2. Then the other thing is the distance between the directrices. We know that the distance from the center to each of the directrix is A over E. Okay, which means the distance between the directrices is going to be 2A over E. So we're going to have 2A over E. That one is going to be equal to the distance between those two. The distance between those two, we're going to have to do 33 over 4 minus -17 over 4 and then divided by 2. So, well, 33 plus 17 this time is going to be 50. So this is going to be 50 over 4 divided by 2. This is going to be 25 over 2. However, we're given that the eccentricity is 4 over 5. From this, A is going to be 25 over 2 times E over 2. Now E, so is eccentricity is 4 over 5. So that means A is going to be 5. So we have got A now, we've got eccentricity. That means we can find C, because we know that the eccentricity is C over A. So the eccentricity is 4 over 5. A is 5. So that means C here is going to be 4. Then we can find B squared. So B squared is going to be A squared minus C squared. It's going to be 25 squared over 4 squared. So that's going to be 9. We can now write the coordinates of, or the equation. So it's going to be x minus, the x coordinate of the center is -1. It's actually x plus 1 squared. Then it's going to be y minus 2 squared. The a squared must divide the y term, because the measure axis is parallel to the y-axis. By the way, our ellipse is going to be oriented something like that. So the a squared is going to be dividing the y term. So a squared is 25 and b squared is 9. This is equal to 1, and that is going to be our equation. All right.